Okay, Jennifer, can you go back to the previous slide? It's not the title slide. Yes. Okay. So hello everyone. My name is Jingwen, and I'm computer science major. My faculty mentor is Dr. Tamar Shinar. Today I'm presenting my honor capstone project. My project is a dynamic simulation of a 3D photorealistic rain scene. Can you move on to the next slide? So my project uses ray tracing. It's a rendering technique that simulates how light behaves in the real world. A lot of people believe that the future of console gaming is looking much brighter with ray tracing and its ability to make light works in the same way as real light rays do. So in real life, light comes to us and bounces on and through a variety of surfaces and reaches our retinas, and our brain then interprets all this like different rays of light into a complete picture. The ray tracing works in nearly the same way, except that everything works backward because a lot of lights never reach our eyes, so they are like not variable when ray tracing a virtual scene. Um, and the picture on the left-hand side describe how the ray tracing works. So the image is pretty much like a retina, and then like the light source will be the real light rays, and then the object will be what we are going to see, and camera is like our eye, like our viewpoint. So in my ray tracing algorithm for each pixel in the image, I compute a view ray, like the ray from the camera, um, the viewpoint. Then I find the closest object that intersect with the real ray, and that will be the object we'll be able to see from the viewpoint, instead of like chasing the light from the light source to the object and then to the eye. I'm chasing it backwards, so from the camera to the object. So if the ray, like the light ray, hits on the object, then we compute how the object should looks like in the image. So for example, like the color of the object, shadows and reflection. And if the ray does not hit the object, then we set the color of that pixel to the background color. So yeah, it's the ray tracing works kind of like backward, and ray tracing let computers accurately render things like shadow, reflection, and highlights. So therefore, it's able to render like photorealistic like scene. Can you move on to the next? Yes. So up until recently, the technique was limited and not feasible for use in video game like real-time rendering, and was used mostly in just the filmmaking industry. The current rendering technique used in game industry is called rasterization, and I know some games are using the combination of rasterization and ray tracing, but it has limitation. Like for the rasterization has a limitation, especially concerning the lighting. Um, the reason why I want to create this project is because the first reason is that ray tracing is one of the biggest topic in computer graphics. A lot of people consider it as the future of virtual world, and I'm very fascinated with virtual reality and computer graphics. So I feel like um, I want to dig deeper into these topics. That's why I decided ray tracing as the projects that I want to do for my capstone project. And also because I grew up in city rains a lot, so rain's a special memory for me. So that's why I want to create rain scene use ray tracing. Um, so my project's goal is to build a dynamic simulation of a 3D photorealistic rain scene using the ray tracing rendering technique. The simulation consists of like mainly three parts: the 3D realistic transparent rain model, photorealistic rendering, and a rendering acceleration. The project proposed a practical solution to how to get raindrop data in the model of raindrops and how to render them in a realistic way. The simulation is programmed in C++ and Python, but mainly in C++. The Python is only used for the wrapper function. And the project will explore modeling, simulation of raindrops, and various techniques of realistic rendering, such as environment maps, bounding boxes, and spatial partition. The results of this project will not just show the rendering of a dynamic rain scene, but also show that the ray tracing method can efficiently and realistically simulate transparent objects. So here's the component I have. and how I implement that. So for the raindrops, I created like multiple 3D raindrop models using Blender to set up multiple test cases. Some have more vertices and some have fewer vertices. I use mesh class. It's a class called mesh to calculate the intersection against the rays and render the raindrops in the scene. And I also have two shader. I created a transparent shader and applied to the raindrop model to make the raindrop looks transparent. Because when I create a raindrop model, it's just like solid model. It's not transparent. So I have to apply a transparent shader to it to make it looks transparent. And I also I also use environment maps to create a background shader that maps my background image to the scene. So I create a acceleration algorithm using bounding box. I created, so for the bounding boxes is that I created an invisible box that encloses each raindrop in the scene. I first check if the ray intersect with the box before checking the intersection for all the triangles of the raindrop model, so that if the ray does not intersect with the box, then I can just skip that raindrop because I would not be able to see that raindrop. That just improve the rendering speed. And for the wrapper, it's like how I'm going to like call all those function together. So I create a wrapper script by using Python, and the wrapper script just basically implement the falling motion of each raindrop in each frame, generate a new raindrop in each frame, and then render raindrops and create output images. And also it also like create a video using the output images. So here's the output images I have. You can see like each raindrop is reflecting the surrounding. So you can look through, so basically the raindrop right now looks transparent and also reflect like the buildings around it. And here's the video. It's just a 5 seconds video. I just try to make it move so it falls. Um, yep. And I noticed that the raindrop at the edge of the wheel are stretched and distorted. If we look back to uh, uh, the output image, the raindrop at the edge, it's kind of like stretched and distorted. Um, but like though I really like the effect because it reminds me the wide angle lenses, like the wide angle effect. But the current version of my code, like my current implementation, was not meant to have such an effect. So I need to detect like why does that happen. And also I have multiple like test cases, and for test cases that have like a large amount of vertices, because some model have like fewer vertices, some model have like more vertices. For those for models that have more vertices, the rendering speed, like it takes like 20 or 10 minutes to render that 5 seconds video, so it takes a long time. So I'm going to improve the acceleration algorithm by adding the spatial partition to my project. And also right now, the raindrop is falling in a fixed speed, so I'm going to like add gravity to the falling motion.